Okay, here we have a kind of big, huge equation here. 6x divided by x minus 1 minus 1 over x plus 1 is equal to 2/3 plus 25x over 5x minus 5. So how do we go about this? What we want to do is get rid of all these denominators. So we're just going to have a linear or quadratic equation. Just get rid of all the denominators. So first off, I want to do a little bit of pre-factoring. I notice there's a 5 lurking here, so I can factor out a 5 there. And so I'll have 5 times x minus 1. So now I'm going to multiply to get rid of all the denominators. So I'm going to multiply all or both sides of the equation by x minus 1, x plus 1, 3, and 5. And x minus 1, I don't have to multiply it twice. I only have to multiply once, and both of them will be gone. And so in total, I'm going to multiply both sides of the equation by 15, right? 3 times 5 times x minus 1 times x plus 1. And when I do that, so you can think about this factor being multiplied to each one of these 4 terms. That's what both sides of the equation really means. And so for the first term, the x minus 1s will cancel, but the 15 times x plus 1s won't. So in other words, we'll have 15 times x plus 1 times the original 6x. Here, the x plus 1s will cancel, as you can see, but the x minus 1 and the 15 will not. And so we're going to have negative 1 times 15 times x minus 1, negative 15 times x minus 1. Whew, that's a lot of algebra coming up here. So 2/3 times this big fraction. Again, we're actually going to have 15 divided by 3. That's 5. So really, it's just 5 times 2. That's 10. Times x minus 1 times x plus 1. Neither of those will be canceled by the denominator. So that's what we're going to have here. And finally, the last term, the 5 will get canceled. So all we're going to have is a 3 here, right? 15 divided by 5 is 3. So we're going to have 3 times 25x. So, well, 3 times 25x. And notice the x minus 1s will cancel when I multiply it, but the x plus 1 will not. So we're going to have 3 times x plus 1 times 25x. So we have a lot of terms here. So let's start simplifying. I'm going to just do one step at a time. So 15 times 6x, right? I'm not going to distribute to the x plus 1 just yet. That gives me 90x. Here I'm going to stay at the same so we can do all things at the same step. Here I'm going to multiply these two brackets, right? You can notice this is a difference of squares, or you can just simply FOIL it, and we're going to end up with x squared minus 1. For the last term, I'm just going to multiply the 3 by the 25x, and that's going to give us 75x times x plus 1. So here, we're simplifying it just a little bit. We still have a lot of terms to go. You can see a lot of distributing we have to do with a lot of brackets. And so we have 90x times x, that's 90x squared, and 90x times 1, that's 90x, minus 15 times x, 15x, minus 15 times negative 1 plus 15 is equal to 10 times x squared, 10 times negative 1, 75x times x, 75x squared, plus 75x times 1 is 75x. So again, boom, we have a lot of terms. Here we go. Final home stretch right here. I'm going to collect like terms on both sides of the equation. So 90x minus 15x is 75x. Here I have what? 75x squared plus 10x squared gives me 85x squared. And I'm going to order it in terms of the quadratic term, then the linear term, and then the constant. Notice we have 75x on both sides. So I can just subtract 75x from both sides. Those will cancel out. I'm going to subtract 85x from both sides, so that kind of moves over to the left, and I'll be just left with 5x squared on the left. And I move all the constants to the right. So I've subtract 15 from both sides, and I get negative 25 on the right. And so I have 5x squared is equal to negative 25. That means divide both sides by 5, and we get x squared is equal to negative 5. And you can see from here, we actually don't have any real solutions, right? X squared is equal to negative 5. If we take the square root of both sides, we're going to be taking the square root of a negative number. And so there's no real solutions. If you are looking at complex solutions, we know that the square root of negative 5, right? We factor out that negative, so to speak, and that comes out as I. And so in other words, our final complex solution is x is equal to plus or minus the square root of 5 times I. If you are not dealing with any imaginary numbers, then at this point you can just say there is no solution, no real solutions to this equation.